Hey there, I'm Liz Abinante. I work here at Relic as a software engineer, and I'm super stoked to be here tonight with Women Who Code and with some of my awesome coworkers delivering some fantastic technical talks. I have seen them all. Get ready. So I don't know how many of you, is this your first Future Talk or have you been here before, newbies? Congratulations, welcome. This is my second Future Talk. I'm really bad at after work events. So if you would like to tweet about us, hashtag Future Talks. And if you want to get in touch with Women Who Code, it's Women Who Code on Twitter. And tonight we're going to start with a little bit of an intro from Women Who Code. Tell us a little bit about what they do, who they are, how things work, and why they're awesome. And then we're going to hear from the women at New Relic, 5 different technical talks. We do have one minor cancellation. Kate, unfortunately, is not able to join us this evening, but I promise she's a wonderful person. So without further ado, Caterina. Do you want an ear mic? Do you want an ear mic?
Hi everyone, I'm Caterina and I'm one of the co-directors for the Portland Women Who Code meetup group. So I have some slides and I just wanted to quickly introduce who we are, what we do, and welcome you to some of our future events. And before I get started, I actually really wanted to thank New Relic. This is an incredible turnout, especially for one of our events. Thank you, Christian, so much for helping organize this. Thank you to Liz for emceeing this and to all the lovely women who are going to present a little bit later. So Women Who Code, we're a pretty big organization, but we're actually rather small in Portland. The mission is really to inspire women to excel in technology careers. 54 chapters, 15 countries, 25,000 members. We've also put on over 1,000 free technical workshops and events teaching women how to code. The Portland chapter is around, I think we're just under 700 members. One of our regular events that we do every week is the JavaScript study group. Have some of you been to one? Yay! Excellent. So we're for that every Wednesday at PDX Code Guild. To find out more about our events, we're mostly on the meetup group. There's also a website, the main Women Who Code website, and then we just joined Twitter on Friday. Yay! So if you want to use, this is actually, there's a Women Who Code International, and then there's a Women Who Code Portland. If you want to use hashtag WWCode tonight, that would be wonderful. I also wanted to tell you a little bit more about this networking night series because we have these events and we had other different study night events. But we just felt like we wanted to put on bigger events and we wanted to meet the companies in Portland and we wanted to showcase women actually working in tech careers. And we weren't going to be able to do that with just study nights. So we started this in March and we've had a lot of really cool companies. New Relic is the 4th one. But we've had a lot of really cool companies do the first 3. And we have a lot of awesome companies: App Nexus, Jama, Urban Airship, Quick Left, eBay, and Nike coming up. So I encourage you to check out our future events. So next month, we're going to be at App Nexus. It's all the tech talks are going to be, the theme is around the world in full stack. So it's going to be a different lightning talk about front end, back end, DevOps, PM, just everything around full stack. Then we're going to be at JAMA on August 4th and Urban Airship on September 9th. And tonight, these are the speakers. One thing that I do want to tell you is that, so this started in March and I reached out to all these companies and I told them that we were Women Who Code. But 3 different companies in the past have all had speakers that were either women or male software engineers. So this, the fourth networking night, is actually the first one where we're going to have a female software engineer presenting, which is really exciting. And it's also really exciting because it's not going to be just one. It's going to be all of these ladies. And there's an MC that's also a software engineer. So this is awesome. But I also wanted to tell you that if you are a woman, if you would like to speak, if you believe in our mission and would like to speak, you should get in touch and I will figure out a way to have you speak. And that's my email. Thank you so much for being here. I think that's all I have. Thank you.
Thanks, Caterina. So we have a theme for our named slides this evening, and the theme is color of hair. So first we have Alice, who has not white, but blue hair. She's a fantastic human being. And I got to tell you, I've seen this talk twice. And you know what? I'm really excited to see it a third time. So put your hands together, everyone, for our first woman this evening, Alice.
Can you hear me? Awesome. Hey everyone, how you doing? All right. Is this too loud? Yes, I hear some yeses that it's too loud. I can just go away. All right, so I will be presenting Docker in a flash. I'm really excited to talk to you about a tool called Docker that we use here, but let's get the important stuff out of the way first. I'm Alice. I'm a site reliability engineer at New Relic, and that means that I deal with servers, the network tier, deployment tools. Basically, if it requires sudo access, that's me. However, before I was an SRE, I was a developer like many of you, and I encountered the following issue 2, 3 times, 100 times. Perhaps it sounds familiar. So I wrote some code. An application or a project, I'm really excited about it, and I can't wait to share it with my coworker. I push it up to GitHub, I drop the link in a chat, and then I take an early lunch because I'm awesome. My coworker, however, is less than impressed. It turns out we both have different operating systems, and it's not compatible with hers. Also, I forgot to tell her that I needed to make a temporary folder in order to store log files in, and if it's not there, the application crashes, and I'm terrible at writing readmes. Anyway, she has to wait until I come back from lunch to get it set up. But we do. She forgives me, and she reviews the code, says it's all right, and I deploy it to staging, where it's awesome, again, because it's mine. It's very stable. I hit all my endpoints. I can even bring it up and give demos to show what a cool thing I have made. And after it's marinated for about a week, I decide on Friday at 5 p.m., I'm going to push it out to production. And suddenly, everyone knows my name. Turns out that in staging, we were testing out CentOS 7, and in production, we were still running CentOS 5. And that dependency in my code brought down the entire site. So what is the common factor between these two situations? It's the environment. Even if your app uses a package manager like Ruby Gems or NPM, it's not enough. It doesn't cover everything. Your environment is more than just your code. It's your operating system, the network tier, even your file system layout. And you can't keep track of all of that in a gem file. You need more tooling. And one of the great ways to control your environment is Docker. Now let's go over some Docker basics. It's a containerization software, which is not a new concept. It actually builds on some other projects like LXC. It's just that Docker has a really good user interface, so people flock to it, and I don't blame them. It's open source, which means that you can follow that handy link and both view the code and contribute to it however you like. One caveat, however, is that it's Linux only. It only runs natively in Linux. There are projects to get it running on Mac and Windows, and that puts a thin VM between the two systems. Speaking of VMs, how many of you here have used virtual machines? Okay, sweet. So we're good. So let's talk about VMs. Assuming you use them only locally, like VMware, VirtualBox, Vagrant, this is going to be a little different than you're running at scale on servers. This is assuming a server environment. So on a server, you've got your host OS, and on top of that is your hypervisor, like ESXi. And that is going to be responsible for controlling your actual VMs. And in this environment, we've got two applications, Application A, Application B. They're both lightweight web apps. Application A is in its own VM. It has a guest OS, let's say it's Windows 7, and that comes with its own binaries and libraries that Application A runs on. Application B, in another virtual machine, has another guest OS, let's say Windows 8, and it comes with its own binaries and libraries that help run Application B. Now, something to keep in mind here is that even if these were two instances of Application A, they would still be separate VMs, even though they both had the same operating system, same binaries and libraries, and same application. And that's why, after a while, virtual machines become huge resource hogs, especially when it comes to things like CPU and I/O. Now, if we're talking about containers, like Docker, it's a little bit different. We still have the host OS, but on top of that, we have a Docker engine instead of the hypervisor, and then we don't even need a guest OS. We go right into the binaries and libraries and the apps. The apps are running down into the host OS. As you can see here, we have Application A and Application B, and Application A has its own binaries and libraries, just like in the virtual machine. But Application B, we have two instances spun up, and they are sharing the same binaries and libraries. And after a while, this really cuts down on the resources you're using. Now, when we talk about Docker, we're going to talk about three main components, and that's Docker files, which are like the blueprints for your code, Docker images, which are the building blocks, and Docker containers, which are shipped instances of your environment and code. Let's take a look at a trimmed down Docker file. This would be located in the root of your application. We've got three things we're telling it. Think of this as like factory instructions. You're giving it exactly what you want to get out of it. And here we want the base operating system to be Ubuntu. We want to install Ruby. And we want to install Sinatra. And when this Docker file is built, those commands are going to become what we call image layers. They're going to depend on each other, but they're also going to layer on top of each other separately, like this. So as you can see, Ubuntu's at the bottom, and that's called a parent image because it doesn't have anything else. It doesn't depend on anything to build it. But it has children images of Ruby and Sinatra. And all of those images together equal your image. And once this is built, all you have to care about is your image. It will reference and pull those other images for you, so you don't have to keep track of those. All you care about is yours. Once you have your image, you can share it locally between two computers, or you can put it in what's called registries, which are like shared storage locations similar to GitHub. Docker has its own public registry called Docker Hub. There's also another project called key.io. At New Relic, we use a more private registry, which I'll talk about a little bit later. Either way, you put your image up in the registry and anyone can get a hold of it. And once you have your image, you can deploy containers. And containers are just copies of your image, just out. If you have an object-oriented programming background, you can think of the image as the class and the containers as the objects that are printed off it. If you don't have an object-oriented background, you can think of your image as a factory mold, just pressing out the same part again and again. So now that you have your image, returning to our previous scenarios, you can just share it with your coworker. As long as she's got Docker, and she can deploy your image into a container, she's great. She's got everything she needs, all built in right there. Furthermore, staging and production both look the same. And you might be saying like, whoa, wait, Alice, okay, like, all right, fine, I get it. Like dependencies in a box, I got it. But, you know, in production, I'm pretty sure there's just a teensy bit more users going on there. Like the network layer might be a little bit, fine, whatever, just launch more. You got a load balancer, add them in, you're done. So at New Relic, like I said, we use Docker and we use it in production. So here's an example of what you might see. We have a cluster of shared Docker hosts, which really frees up provisioning resources once you get down to it. And for every service that we have Dockerized, we deploy at least 3 instances. One is the actual instance that's required running in production. The second one provides for N+1 redundancy. And the third one is for maintenance. So let's say the green box is our Insights UI. I don't know if any of you here are really familiar with our product suite, but we have a product called Insights, and the UI is actually completely Dockerized. So let's say that the green box is the UI, and I, in operations, want to take down Docker 4 because I don't like the way it looks at me. Well, I can, because Insights is already running on the 2 other hosts, and it actually just needs 1 to function anyway. So I can do that. I don't have to tell the development team, which I like, and I'm done. To get Docker running in production, we have both created and maintained several open source tools. The most important ones are Centurion, which is our deployment tool. It allows you to do a rolling deploy of containers across a variety of hosts in different environments. And Dogestry, which is, yes, Doge, which is based on that private registry I was telling you about, as opposed to Docker Hub and Key.io that have the images publicly accessible. Dogestry allows you to set up a registry privately using Amazon S3 buckets, so you can keep it in your own wheelhouse. And that's it. Thank you very much.
Yeah, I have power again. So I have to break away from the slides matching hair color theme. However, I can rest assured to tell you that these 2 ladies don red capes regularly. They are 2 heroes at this company, and they're on my sister team, which makes them even more awesome. So Katie and Zoe are here today to talk to us about upgrading Rails. Can we give them a big, huge round of applause?
Thank you. Ooh, wow, I can hear myself. Hi. Hi, everyone. I'm Katie. This is Zoe. And we work on New Relic's APM user interface. And for the past 6 months, we've been upgrading the site from Rails 3 to Rails 3.2. And tonight, we want to share why we think it's important to upgrade, some of the bugs that we found, and some of the larger lessons we've learned along the way. So first off, there are a lot of really good reasons to upgrade, but the single biggest reason is security. The Rails community continues to find new security problems for all versions of Rails, all the way back to 1.1. The problem is that patches are only provided for the newest versions. If your Rails version is no longer supported, you're vulnerable to all kinds of threats. There are alternatives to upgrading, such as ignoring the threat, and depending on how much user input you process, this could be totally reasonable. Another alternative is to backport the patch built for later versions of Rails, and we've used this approach in the past, but it's a little like upgrading your app 1 method at a time, which is a little difficult and time-consuming. So security is one good reason to upgrade your app, and data accuracy is another. So time zones are an example of how your Rails version could be interfering with your ability to display accurate data. As some of you may know, time zones are the trickiest part of displaying time series data, and this is what used to happen to us when daylight savings time rolled back an hour in the fall. We would collect data for the hour of 1 a.m. to 2 a.m., and then we'd roll clock back, and we'd recollect that hour of data and display it in the graph. But only if the user participated in daylight savings time. Portland users might see this graph, but Arizona users would not. So our graphs are only as good as the data we have, and time zone data is encoded in the TZ info gem for Rails. It is updated regularly as governments opt in or out of daylight savings time. But Rails 3.0 has an internal dependency on version 0344, which is about 20 versions old. So if you're working with date and time data from users in, say, Argentina, you might be off by an hour depending on whether they've opted into daylight savings time or not, which they do on a yearly basis. So in Rails 3.2, they removed the dependency on this gem, which frees us to keep the time zone info up to date. So we have security and we have data accuracy. And my last pitch for upgrading your Rails app is developer happiness. It is so painful to sift through outdated docs and blogs and to read about cool new features that you can't use in your day-to-day work, like using the pluck syntax to pull a field from database rather than account, connection, select values, and then some raw SQL. Rails is getting better, and we deserve to use new features that make our code cleaner, more readable, and more maintainable. So security, data accuracy, developer happiness are all awesome reasons to upgrade, but you might be wondering why we waited so long to get started, or why we're stopping at Rails 3.2. Well, there were many changes to essential Rails internals between these two releases. Rails added an asset pipeline. They refactored the query and association syntax and overhauled their routing engine. And they also added jQuery as the default JavaScript framework, just to name a few of these big changes. And our application began with Rails 1.2, which means 7 years of building features with state-of-the-art technology that is now deprecated. So this is why upgrading is a big challenge. You'll be spending most of your time in the oldest parts of your code base and the brittlest parts of your test suite. So digging through 7 years of features, we found a few of our features that were deprecated and they needed some reworking. And as I mentioned before, Rails 3.2 declared jQuery as the default JavaScript framework, which meant that support for the existing framework was deprecated. And this framework was RJS. RJS is a templating system that allowed developers to build dynamic pages without writing any AJAX. You could build your script into a string using Ruby instance variables and then inject the string into the page. Templates like this one were really easy to replace with plain jQuery, but others required more creative solutions. Rails 3.2 was released in 2012, and jQuery had just taken over. And today, apps have even more sophisticated client-side layers, and it won't be long before we'll be revisiting these decisions again. So when the Rails internals changed, they not only broke our own code, but they broke many of the gems we'd included along the way, such as Formtastic and Active Scaffold. Active Scaffold is a gem that promises to save you time by creating all the CRUD actions you need and user interfaces required for direct interaction with the database. And it did. Here's the admin page for my Gem and the Holograms fan site. I built it with Active Scaffold, and I can create, read, and update and delete records at will with only a few lines of code. Easy peasy. So easy that you can set it and forget it for 6 years. Until you try to upgrade. So, significant changes between Rails 3 and 3.2 causes all kinds of havoc internally for Active Scaffold. The location of templates and assets have moved. The HTML and CSS selectors are also generated differently, so any custom JavaScript you might have built into these pages is now broken. And helper methods you've added now require different method signatures, and you have to dive into the gem to discover it. So upgrade bug hunting will take you deep into the libraries you use, and sometimes even into the language you're using. Take clone and dupe, for example. With simple Ruby objects, clone and dupe do pretty much the same thing. They copy all the data from object A into object B, and changes to either do not affect the other. This is not the case with Active Record. And the behavior is also inconsistent between Rails versions. So in Rails 3.0, calling clone on an object gives you a shallow copy. Property values are the same, but changes to one will not affect the other. Dupe, on the other hand, gets you a deep copy. Changing a property on the duped object will change a property on the original object. In Rails 3.2, these behaviors are reversed. Yeah. I know. It's a tricky one, Rails. So a duped object does not share properties with the original, but a cloned object does. This created a bit of havoc in our code and in our test suite and made for some very messy interim code. So we've learned more than a few lessons over the course of this upgrade. One is magic is inherently unstable. If a library offers to do it all behind the scenes, you're in for a really bad time when it comes to upgrade. Another lesson is examine the magic output. You will get hard copies of objects instead of soft copies, or the SQL will change or be munged under the hood. And Zoe's going to share a few more lessons that you can take away.
Hey, can you hear me? Yeah, it sounds like it. So, I'm Zoe. We learned quite a few things along the amazing upgrade path. And I was going to take you through some of those. Yeah, so basically we found some issues. We ran our test suite, we fixed the tests, and it was pretty much done. right? I mean, your test coverage covers everything, so we're good to go. Just kidding. Tests are great, but they're more of a starting point than a be-all, end-all, especially for an upgrade where, like Katie said, there's a lot of internal changes in Rails. You have a lot of small changes that mean a lot. And there's also no definitive page of changes for that version. So you have to discover them on your own. And we developed some strategies to do this. So one of those was upgrading one minor version at a time. So instead of jumping directly from Rails 3 to 3.2, we stopped along the way and smelled the 3.1 roses. They were very nice. And the main benefit here is deprecation warnings. So this will save you some time and effort if you are upgrading. Here, we have a deprecation warning for errors.on. And this way we can see this when we run our server. We can look in our code, we find where we use it, replace it, and we're done. We can move on. If we hadn't done that, if we just moved straight to 3.2, we might get a traced error or get an error in our product, go find where we're using it, see that it's deprecated after some research, fix it, and it takes a lot more time and effort. So this was one strategy we had. Unfortunately, RJS was deprecated. There's no warning for that. They just stopped supporting it. And so this led us to using visual comparison. And one of the really helpful tools with this was running the same code in the same environment on Rails 3.2 and Rails 3 with the same data and everything so that you can very easily see, is this an upgrade bug or is this just an existing bug across both versions? And this is really helpful so that you don't have to dive in and try to debug, but you can also ask other teams. So if they say, hey, I think this is an upgrade bug, and you're like, well, did you test it in both and it's still there? That's our problem. If it's not, or other way around. So if it is in Rails 3.0 and 3.2, that's your problem. But if it's only in Rails 3.2, then it's our issue. It's part of the upgrade. So yeah, one of the issues we found with this was this chart right here. We have a lovely x-axis down at the bottom, and unfortunately in Rails 3.2, that suddenly disappeared. So we spent some time debugging this. We looked at our controller request right here, and you'll see that hide x-axis false Boolean we're sending in. And as you'd expect in the params, it passes us that Boolean false, so don't hide the x-axis. When we get to Rails 3.2, this is something that also changed. That Boolean suddenly becomes a string. So when we evaluate this in the controller and we decide whether to hide the x-axis or not, we look at this in Rails 3.0, we say false, don't hide it. But in Rails 3.2, a false string evaluates as true, and we start hiding the axis there. So we had some strategies to find these kinds of things, deprecation warnings, visual comparison. One of the things that turned out to be a tool to find bugs was actually our rollout itself. So we have a development environment, a staging and production environment. And once our errors had gone down, everything seemed stable. We decided to roll out to dev, try things out. So we worked on we rolled out to dev. We have 2 servers. We rolled both out at the same time. Everything was awesome. Didn't see a lot of errors. Things went smoothly for, a week or 2. We decided, I think it's time for staging. And we use our staging environment for some critical functions, so it's really important to keep stable and keep up. So we decided to lower the risk of breaking it, roll 3.2 onto one of those servers, monitor it for half an hour or so, and then if it's ready, roll it to the next one. So this didn't go so well. We got a big error rate spike. People started complaining about having 500 errors in login. And it turns out that the session code in Rails 3 changed in Rails 3.2. So let's take a look at that. So again, we've got Rails 3. we have this class flash hash that inherits from hash. And in Rails 3.2, that's changed, and we're not inheriting from hash anymore. So when a request is made on Rails 3.0 and it saves the session, when that user makes a request to Rails 3.2 server, it tries to read that flash hash, and it can't find the class with the same inheritance. It raises an error because it doesn't know what to do, and everything's broken. So the reason we found this in staging was in dev, we rolled out to both servers at the same time, and they were able to talk to each other really well. But when we rolled out to staging, we had one on 3.0, one on 3.2. They can't communicate because of that class difference. And so what we took away from this is that the rollout itself is an important bug discovery zone. And after this, we made a rollout plan. We looked at the variables in production, and we said, okay, this is what we're going to do for production. Let's try to reproduce this as early as possible in a dev environment so that we can catch these errors earlier. So, upgrading is really important. It makes developers happy. It makes your security people happy, which makes everyone happy. And it's really important for dependencies for other things that you're going to need to upgrade eventually. Also expect to work in your oldest code. It's going to be deprecated, or it might be incompatible with new changes. So that's one of the things we found. And then obviously fix your tests, but there are some other tools you're going to need and probably use to discover other issues. And perhaps the most important thing is, or what I want to encourage, is upgrading as you go. And so don't put off the upgrade work until it piles up. So it'll be easier to track down issues with current information as everyone else is doing it. Your developers will be happier, your code base will be happier, and it will be a faster process overall. Thank you very much.
Huge round of applause for those ladies, please. They worked so hard on that upgrade. So next we have Ashley, and she's going to be talking to us about performance, which is actually really interesting. I've only gotten to know Ashley fairly recently, and one of the times I had to come into the office very, very early, about 6 a.m. My dog was sick. I needed to get my laptop so I could take my dog to the vet and work at home. Ashley was in the office, working out. So if anybody can speak to us about performance, it is clearly this Blue Star athlete, Ashley. So please, big round of applause with your hands for Ashley.
Can everyone hear me okay? Good? Okay. My name's Ashley. I am a senior software engineer here at New Relic on our Java agent team. And I'm going to talk to you today about performance. Performance is defined as the act of accomplishing a task. This task could be playing in a soccer game, singing at a concert, dancing in Dancing with the Stars. Regardless of the task, you generally define success somehow. If you're in the Olympics, this could be winning a gold medal. For us, as software developers, performance is our code running in the production environment. And success really depends on the requirements for the application that we're writing code to. And this is really important to define your requirements before you start doing any performance testing, because ultimately you want to test to your performance. Now, suppose you're writing code for a pacemaker. Number one goal, keep the heart beating, right? Here we're really concerned about the worst case. What can go wrong that will allow the heart to continue beating? So this means we're going to have a requirement, something like generate pulse after every heartbeat 100% of the time. Now, let's change and say we're creating a website. Here we care about keeping users on the page. And so our concern is the typical behavior. If one or two people have a really slow experience, that's unfortunate, but they'll still be alive to buy their shoes the next day. We're not going to kill them. So here we might have a requirement, a page must load in X milliseconds 90% of the time. At New Relic, I work on our Java agent. And how many people have used an agent here before? All right, not that many. So an agent is the code that runs inside an application, and it extracts the metrics that we show you in our UI at New Relic. And so what's really important here is we want to extract as much information as we can so you can diagnose your performance problems. However, we don't want to impact your application. So here we have a requirement, maintain a nominal overhead. We have to make sure that we're keeping out of your application as much as possible and just reporting the critical data that you ultimately need to solve your performance problems. So here we have 3 applications, 3 requirements. So now we're ready to travel down the road to success. But before we go too far, we need to pick what direction we want to go. And this is similar to what tests do we want to run. There's a variety of tests out there, load tests, benchmark, stress tests. And I don't want to go into a lot of detail into the tests, but be aware of what type of test you're running and make sure you pick something that's going to help you determine whether or not you're meeting your requirements. So as you pick your path and you travel down the road, you need to watch out for signs. Describes performance testing. Downgrade next 9 miles through heavily congested area. Descend in low gear until notified. If brakes fail, ditch truck immediately. Proceed with care. So when you're performance testing, it's really easy, just like the truck, it's really easy for the truck to get to the bottom of the hill. It's really easy to get numbers when you're performance testing. It's much harder to get numbers that you trust. So that's similar to the truck and the brakes, right? Do you really trust your brakes? Do you really trust your numbers? You need to proceed with care. And so now I'd like to talk to you about a word of caution and some of the performance frameworks out there. Just because you're grabbing a framework from the internet doesn't mean that you can automatically trust it. There's a lot of common issues in these type of frameworks. So number 1, warning. Headroom and width of tunnels varies. This is similar to your computer. When you're performance testing, nothing else should be running on your computer. Get out of all applications. And here's just a quick little example. I set up a little test servlet, and twice while the servlet was running, I started a background process. So here you can see a significant change in the response time just by one background process running. All right, this is going to drastically skew your performance tests. Number 2, you need to warm up your system. Here's this same application, and this is the startup. And you can see it's significantly higher till after it warms up. And generally, there's multiple components of the system that need to be warmed up. So I typically work in Java on the JVM. So the JIT has to warm up. The garbage collection has to warm up. We want to run through all the paths that we're going to be testing so that we have all the initial object allocation out of the way before we start our test. Number 3, sign not in use. Especially on the JVM. The JVM is actually pretty intelligent, and you might write this nice little test code and you run it 1,000 times and you get like 1 nanosecond of performance. You're wondering what happened? Well, the JVM realized that you're not doing anything with this code. You're just running it. And so why run it at all? So you need to make sure that the code that you're expecting to test is actually being run. Number 4, call 511 travel info. So here I want to describe the term coordinated omission. Has anyone heard of this before? It's a term coined by Gil Tenney, who's the CEO of Azul Systems, and they create their own JVM, and he's considered a performance guru in the Java field. And what this is say you want to describe or figure out what the performance is of this travel info call center. So you decide you're going to spend your day today calling every minute from 9 to 5. And you're going to say that they're successful each time if they answer the phone within 3 rings. If it goes to 4 rings, that's a failure. So you call at 9, they answer. You call at 9:01, they answer. They call at 9:02, they answer. Everything's going well until noon. At noon, the phone rings and rings and rings. And in fact, it rings all the way to 1 o'clock. Well, why? Lunchtime. The secretary went to lunch. So at 1 o'clock, she comes back, and sure enough, 1:01, 1:02, they're all successful again. So you calculate 420 successes and 1 failure at noon. This is a 99% success rate. Great, travel info, call center, they're doing an excellent job. No, right? What you should have done is called up your friends on your second phone, because you're busy with it ringing, and had one of them call at 12:01, 12:02, 12:03, etc. And what you actually find is that you have 420 successes and 60 failures. This is a success rate of 87.5, significantly worse than our 99% success rate. And this is called coordinated omission. And this is very common in load testing frameworks, right? Essentially, you have one result that's taking a long time, and so all your other tests are delayed and not getting sent to the server like they should. So be careful. All right, so we've gone over a few got-yous. So now, in case of fire, exit building before tweeting about it. Think about your performance results, verify that they're correct before you tweet them out to the world. And if you're needing help, go look at what the experts say. In Java land, these are two of my favorite people to follow. Alexei, he's written a benchmarking framework, and he also worked on the Open JDK. And Gil Tenney, he's the one that came up with coordinated omission and is the CEO of Azul Systems. So hopefully now you're at least aware of the whales in the ocean, and you won't get thrown from your performance boat. In summary, define your performance requirements, test to the requirements, and beware of performance framework flaws. Thank you.
We are once more reunited with hair colors and slides coordinating. I'd like to introduce you all to Kay Wu. Kay Wu is one of our software engineers here, and I'm very pleased that she's on my sister team for the next week, and then she's going to be moving to one of our agent teams. So she's hardcore. When you think developer hardcore, you think Kay Wu. I have a little story about Kay Wu that's actually like melts my heart. It's a little my cold black heart. I've only been working at New Relic for about 7 months or so. And last year I lived in Chicago and went to RailsConf. Super, super awesome conference. So many people. One of those people was Kay Wu, and she was giving a talk about how to be a better junior developer. And I went to this talk, and I was like, wow, she's really cool. It seems like she works for a really cool company, but I could never work there. I'm not good enough. See? It's so sad, right? And so like I left RailsConf, and I was like, okay, maybe someday I'll be good enough to work at New Relic. Maybe someday I'll get to know the great Kay Wu. And then lo and behold, about 6 months later, came to work in New Relic, and I sit across the aisle from the great Kay Wu, and we stand at our desks every day and dance together. So put your hands together for Kay Wu.
That's so sweet. I didn't know you were at that talk, actually. That's so cute. By the way, in case you didn't know, like all of us at New Relic that got our hair colored, we actually do go to the same person. So let us know if you like need a stylist recommendation. She's awesome. Anyway, so to go back to a little bit back about technology, I'm Kay Wu. It's short for Katherine Wu, but we already like even in this small sample size, there is another Katie, and like this happens all the time. So everyone calls me Kay Wu, and I'm here to talk a little bit about a recent project that I worked on, which is where we wanted to move out from active record to using a service instead. So a little bit of an overview of what I'm going to cover. First, in case you're unfamiliar, I'll talk a little bit about what active record actually is, and then why we would want to do this project and stop using it in the first place. And then I'll go over a little bit about the general architecture of what it looks like to transition to a service instead, while also talking a little bit about the different steps to doing that whole conversion. And then I'll leave you just with a couple tips that I learned from this effort. So first, again, what is active record? When you think about the model view controller of looking at web frameworks and Ruby on Rails, active record is the model portion here. It's what you use to have object representations of data and tables in your database. And so by using active record, you get lots of really helpful magic here for working with that database. And so, for example, you can retrieve your data without having to write a ton of SQL queries by hand. And so it's very conveniently packaged up in there. And so if active record is so great, you might be asking yourself, why would we want to stop using it? Well, when you have an app that's been around for a few years, its database can start to get a little bit full and unwieldy. Kind of sad puppy. So because Active Record it's a bit too closely tied to that database, it makes it hard to improve how you store that data while still keeping things running as normally as possible for your customers. So that's why we have this project. If we extract out certain models to go from Active Record to using a service instead, that service can be responsible for how the data is stored and improve and upgrade it totally behind the scenes. So this is one of those projects where if everything goes really well, then nobody will notice anything different from the front at all. So to talk a little bit about the general architecture of how this gets put together. Typically, this is what you might see in your Rails app to start. You have a controller where you want to show a puppy, so it asks your puppy Active Record model to find you that puppy from the database. And so for this conversion project, what we want to do is introduce this indirection layer in here, which goes in before this bit where you're trying to get the data out of your database, wherever that may be. So to dig in a little bit what that indirection layer looks like, we have now this puppy client object that we're going to put in there. And so rather than issuing calls directly to Active Record, we have this client where we can put in a feature flag. The feature flag will allow us to choose whether we're going to fetch data in the old way, sort of going through Active Record again, or for enabled accounts to go through the new way to using the service instead. And so this way, we don't have to make the change to using the service entirely all at once. We can go a little bit more gradually and therefore a little bit more safely as we introduce this change. One more point, which is, so the other nice thing about having this client with these adapters is that we knew that we would eventually want a V2 version of the service. And so when we got to that point, we could just introduce a new V2 service adapter, amongst our 3 different options there, just as another piece, and then we can flip back and forth from that. So it makes upgrading much easier. And so to fit everything back into that larger context again, this is what the new setup would look like overall. Once we have that client layer in there, everything in our app that needs puppies, which is lots of areas of the app, we could always use more puppies, right? Now it has the standardized interface to find those puppies, regardless of where they actually live currently. So everything that's in this purple box would be new. And that's really the core part of the project, is inserting in this new layer here. The top part here inserted, highlighted in green, would have to change slightly as well. Though the core part is that new layer of indirection here. For this particular project, a different team had built the data service for us with its shiny new database, so we didn't have to worry about that part. We could just use it. And so in terms of the conversion process, there were 4 overall steps. 1, create the client. 2, refactor everything to use that client. 3, create the different adapters for each direction that we'd be going in. And then 4, convert each of the functions over one by one. So I have a couple short code examples for each of those steps. So the first one, for creating the client, it's pretty quick, this initial one, because the client is initially going to just direct all of those relevant queries straight back to the Active Record model. So it shouldn't change anything besides just adding in this extra step for queries. And so that when we move to step number 2 of refactoring everything to use the client instead, whereas before we might call something on, this find method on the model directly, now we're going to call find through the client instead. And we know that currently behind the scenes, the client's find is just redirecting to the model's find method, but that's totally fine. We're just trying to do this as incrementally as possible. And so step number 3 here, we're now adding this method into the client that will let us have a feature flag to control what direction we're going in. So I'll just go through this line by line. First, some general setup. And so this line, if using puppy service, that's sort of the general syntax of how we might have a feature flag. And so if we are in fact using the service now, we're going to call this a new instance of the service adapter here. But if we aren't and we're going through the old pathway, we're going to create a new instance of the Active Record adapter instead. And this kind of helps us keep these two pathways clean and neat. And so again, now in that client, whereas before, when you called the find on the client, it actually just ended up calling the find on the model directly. Now we can change it so that it calls find on the correct adapter, and you use the feature flag to toggle between the two depending on which step of the conversion you're in. And so finally, on the active record side, because that's just the same it was before, you're calling the find method on the model directly. But in the adapter now, in the service adapter now, you can call find through however the service requires that you call that find method there. So there'd be additional setup here in terms of how you actually discover that service and how you connect to it and issue the command depending on the service's IDL that we had. And so finally, for step 4, from there, we're going to work on converting each function over one by one so that you end up having corresponding methods in each of the different adapters. So I'd have a find method in the active record adapter and a find method in the service adapter. Same thing for search, and same thing for any other special methods that might have been created back when you were probably overloading the model with lots of other responsibilities. So, once we do that, we went through and updated all these methods to accept the same standardized inputs. And occasionally they would have to be modified slightly for the individual adapters, because sometimes, the key names might have changed slightly between the two, or one of the sides, had extra parameters than the other. And so we could delete it from the side that we didn't want it on. And so the adapters would be a really great place to take care of that kind of thing. So to wrap up, just a couple of quick tips from the practice that I learned. The first thing, hopefully this is okay to say, but it turns out that deleting code is totally a legitimate way to fix some of the broken tests in there. Yeah. So I do have, I do have a legit explanation by this, which is that, we had actually a fair amount of test coverage for some of these different areas, but some of them turned out like they were really tightly coupled to the active record model because they tested things like the structure of the data. But that is now the service's problem, not ours. And so it wasn't worth the time to go through and painstakingly update and fix all those tests. The effort as well to understand what the test was doing really, once we could determine that, do we actually care about the results of this test? And if the answer was, as long as the service does its job and gives us what we asked for, then we're fine. Then we could get rid of that test, because we should be able to trust that the service will, hold up onto their end of the contract there. So that's number one. Number two, so as a very similar lesson to what Katie and Zoe talked about in the Rails upgrade, we found that it's really useful to run things in staging for at least a couple weeks while you're rolling it out. Because of all the Rails magic that's happening behind the scenes, sometimes there were places in the code where we hadn't thought to search on something that, it still referenced the old logic, or there's some places where we had an incomplete conversion, and so it wasn't exactly in the right format for the different structs that we used. And, sometimes even, we had test coverage of that, but we weren't necessarily in all of our tests going back and forth and flipping the feature flag so that it was going through both the old pathway and the new pathway. And so it was still helpful to kind of have a gradual rollout again to keep things stable and make sure nobody knows anything is happening there. And so lastly, this is the first project that I'd worked on here where I'd really worked quite so closely with another team to use something as they were building it. And so at first communicating back and forth could be a little bit of a challenge, since I didn't know if it was something, in how I was using the service, or if there was genuinely a problem and, something on their radar is like a bug they needed to fix. And so one thing that really helped expedite these things was to just send them the exact query we were using to try to fetch things from the service. Because sometimes, the answer would come back and they would say that actually the query is constructed incorrectly and it was a misunderstanding in how to use the service. And sometimes, it was definitely much more, that there was in fact a bug in the service there. So really a good lesson learned. Thank you very much.
See, I told you she was hardcore. So last, but absolutely not least, we have Emily. And I have to say, Emily and I don't work on the same team. We don't even work on the same product. We don't even work on the same floor. However, we are both incredibly passionate about pixel perfect interfaces and clean, beautiful code, and most importantly, fonts. Fonts are the most important thing in the world. And in case this 30-second spiel on Emily and I and our obsessiveness with the way things look and how happy they make us when they're clean and pretty, not only does this slide match her hair, but it also matches the purple in her slides. Ladies and gentlemen, Emily.
Hey, so I'm going to be talking about programming for humans, because the actual consumers of almost all of the code that you write are actually the other people who need to read it. The computer really doesn't care what your code looks like. So the idea here is to apply some of the principles from user experience design to designing APIs and designing code. So I'm Emily Highland. I'm a senior software engineer here at New Relic. I work mostly in Ruby and JavaScript. And so I'm going to talk a little bit about kind of a few different aspects of this. So first off, who do I think can really benefit from using these ideas? What are some of the terms from user experience design that I think are useful in code? Why I think this approach is a good idea, both generally and versus other ways to accomplish similar goals. What points in your development process to apply these ideas, and then just a few little tricks for how to get yourself into the right mindset. So who is this for? I think this is really for everyone. Even if you never write a gem that you publish or a public-facing API, there's still going to be other people reading your code. Even internal code is going to be used by the other people in your company. And a side project, you're going to need to read that code 6 months from now, and 6 months from now you is basically a different person. And so you're being your own friend here. So some of the terms that I want to talk about. First, I want to say a little bit what I mean by APIs when I'm talking about designing your APIs. The first thing you're probably going to think about is remote calls that are exposed to consumers. So maybe your, JSON over REST API or the API that your gem publishes. But for something like this, I do think you should think about all of your code as an API. Every class you write has some methods that it makes available to other classes, and those methods have names and signatures. Even the variable names you choose inside of your methods help to make clear what those methods do and how they're supposed to function. So when I'm talking about user experience, I'm talking really about the subjective experience of using your software. So this isn't something that's going to make it work or not. It's going to be how easy it is to use and how you feel while you're using it. We've all used code that we feel like we're fighting with every time we want to do something, and we've used things that just work the way we expect the first time. And part of what makes that difference of whether it does what you expect or not is the concept of affordances. So an affordance is the idea, it's what tells us to make the push handle and the pull handle on a door look different from each other. It's how you know what something should do before you use it. So it's going to be the properties of an object that it shows you that tell you what you can do. And so when you're defining methods in your code, you're creating affordances for all of the other engineers who are going to use that code. So why do I think this approach is a good idea? One of the big benefits here, and one of the things that kind of got me started thinking about this, was being able to reuse knowledge. So in Ruby, for example, if you know how the each method works on an array, you probably have a pretty good idea what it's going to do the first time you try it on a string. And so when you have this knowledge that continues to work when you try it somewhere else, that's really useful. And it lets you really build on top of the things you've already learned instead of having to learn it over and over again. And that's, you learn that the handles that look like this mean push. And I think one of the other things that it gives you is discoverability. When the name of a method tells you what it's going to do, it's much easier to jump in, look through, all right, well, what are the methods on this class? If they're just, method 1, method 2, method 3, you have no idea what you're going to get. And that's obviously very exaggerated. But sometimes we see code that almost feels like that. But you can give things really descriptive names that make it clear what they're going to do. But the reason I really like this approach and not some other approach to accomplishing the same thing is I think it lets you tap into a really different part of your brain than you're usually using while you're writing code. You're using your empathy for the people who are going to come and use this code after you. Instead of these abstract, dry best practices and design patterns of, well, if you follow this rule, something will be better. This is, well, why am I following that rule? How is this going to affect the other humans who need to use my code? And I think tapping into that and reminding yourself of that is really useful. So when do you want to apply these ideas? The most obvious time, but in some ways the hardest time, is while you're writing code. Once you're down in the trenches of your code, you know exactly what you mean. And so it's really hard to know whether that method actually, does that name actually make sense? And so it's useful to step back every so often and reconsider your approach and think about what this might mean if you didn't already know. But that's really hard to do. But there's another time where you're already in exactly the right mindset. And that's during code reviews. You're looking at some code for the first time and you're deciding whether this is good code that you want to live with and that you want to maintain and own. But it's new to you, and so you can really take that moment to think, as you're reading a method, read the name of the method. What do you think it's going to do? And then you read the code, and is that what it actually does? And it's a really natural time to do this kind of thinking. And the last time I think that's really helpful to think this way is when you're choosing tools. You can look at the documentation for a library that you're thinking about pulling into your project and see, is this well documented? Do the methods do the things I think that they would do based on their names? Is this something I'm going to fight against, or is it going to help me be as productive as possible? So a couple little tricks to try and get your thinking kind of aligned this way. One really good thing is to try to follow conventions, whether those are the conventions of the language you're working in or the code base you're working in. See if someone has done something similar and how they've done it. Make sure you use consistent naming for things that refer to the same concept. That's one really easy way to kind of help with that discoverability and that reusable knowledge. Another thing to do is to try to imagine the person who's going to be using your code and think about what their goal is going to be. Why are they here using your code? It's not just to look at it. They have something that they want to get done, and you can think about what you can do to help them get that done as easily as possible. And then the last thing that I think is kind of a fun little trick to capture the right frame of mind at the right time is before you start writing code. If you're starting on some biggish new project, if you're starting on a service that someone else is going to consume, before you write your first line of code, write the README. Because you're not thinking yet about the implementation. You're not thinking about how hard it's going to be to write that method. You're thinking about what method you would want to be there when you try to use the code. And so that's a really great time in your process to be able to do this. So that kind of takes us through some of the basic ideas around using UX concepts to think about code. This is kind of an idea I've been tossing around in my head for a long time, but one of the things that really helped me to sort of crystallize it and to put it into the language of user interface is this quote from Mats, the creator of Ruby. So programmers often feel joy when they can concentrate on the creative side of programming. So Ruby is designed to make programmers happy. I consider a programming language as a user interface, and so it should follow the principles of user interface. And that's it.
Thank you, Emily. Hey, everyone. So I just wanted to say a quick thank you to everybody for coming, and a huge thank you to Christian and Caterina for putting this on, and our wonderful speakers, who I'm so excited to work with every day. One last thing. Women Who Code has coordinated with Open Source Bridge, which is a local conference. I'm not sure if any of you are familiar with it. It is super awesome. It is actually one of my favorite conferences in the entire universe, excluding Mars. The whole breathability thing. So they have a discount code for $100 off tickets. I'm going to say it now, but if you don't have a pen or pencil, Caterina can give it to you later. It's at the end of this month, the 23rd to the 26th. It is a non-technical specific conference, bunch of different stuff, bunch of awesome speakers, hugely diverse group of speakers and attendees. It's OSB UGLUV. So that's OSB User Group Love is the discount code for $100 off a ticket, which is pretty sweet. But anyways, I think most of the ladies are going to be sticking around for the evening. Don't let Alice's scary picture of the scary dude scare you away. She's a very, very wonderful person. No, Alice is awesome. And if you have any questions about Docker, I promise you she will talk to you as long as you want her to. She's very excited about it. So again, thank you so much for coming. There is still, I think, probably beer in the back, beverages in the fridge, probably still some pizza. And again, on behalf of New Relic and Women Who Code, thank you all so much for coming and supporting our awesome women in engineering.